Hey, hello there, and welcome back for more Advent of Code. So, it is already 2024, and well, still haven't finished Advent of Code 2023, and I actually don't even remember where we were. Day 22, it seems. What was day 21 about? This infinite thing. Yeah, it was a nice one. But yeah, I couldn't finish this for Christmas, and last week I was out and couldn't really. Well, I wasn't here to continue on with the puzzles, but I really want to finish them. So let's give it a try and see what's next. So day 22. Let's also remember and appreciate what we have already done in the Advent calendar. Like we have restored the lava flow, the machine parts flow, and the sand. And now we are in this island. And day 22 is about sand slabs. All right. Enough sand has fallen. It can finally filter water from Snow Island. Well, almost. The sand has been falling in as large, compact bricks of sand, piling up to form an impressive stack here near the edge of Island. In order to make use of the sand to filter water, some of the bricks will need to be broken apart, nigh disintegrated, back into freely flowing sand. Okay. The stack is tall enough that you have to be careful about choosing which bricks to disintegrate. If you disintegrate the wrong brick, large portions of the stack could topple, which sounds pretty dangerous, indeed. The elves responsible for water filtering operations took a snapshot of the bricks while they were still falling, your puzzle input, which should let you work out which bricks are safe to disintegrate. For example, this thing, what is this? Each line of the text in the snapshot represents the position of a single brick at the time the snapshot was taken. The position is given as 2 XYZ. Oh, okay, we have a 3D puzzle. XYZ coordinates, one for each end of the brick, separated by a tilde. Each brick is made up of a single straight line of cubes, and the elves were even careful to choose a time for the snapshot that had all of the free-falling bricks at integer positions above the ground. So the whole snapshot is aligned to a 3-dimensional cube grid. Okay, nice. Is this then a grid puzzle? Another one in this Advent of Code, but this time the first one that is 3D. Well, we shall see. So, okay, and these brick things are straight lines. Yeah, straight lines of cubes. So yeah, you can see that they differ in only one number, I guess. Yeah, here's the x coordinate, then it's the x coordinate again. Okay. And they are all integers. A line like 222 means that both ends of the brick are the same coordinates. In other words, that the brick is a single cube. Lines like 0010, 1010 or 0010, 0110 both represent bricks that are 2 cubes in volume. 2 cubes in volume? Yeah, it's only moving one, okay. Both oriented horizontally. The first brick extends in the x direction while the second brick extends in the y direction. Great. A line like 001, 0010 represents a 10 cube brick which is oriented vertically. One end of the brick is in the cube located at 001 while the other end of the brick is located directly above it at 0010. Great. The ground is at z equals 0. And it's perfectly flat. The lowest set value a brick can have is therefore 1. So 551, and 021025 are both resting on the ground, but 332, 333 was above the ground at the time of the snapshot. Okay, so the snapshot is taken while the bricks are still falling. So this is this kind of Tetris kind of puzzle. Because the snapshot was taken while the bricks were still falling, some bricks will still be in the air. You'll need to start by figuring out where they will end up. Bricks are magically stabilized, so they'll never rotate. Oh, nice. Tetris rotations are not as easy as they seem, especially if you do like the very lenient kind of rotations. Anyway, that's I'm already thinking about Tetris. Even in weird situations, like when a long horizontal brick is only supported on one end. Okay, yeah, so they behave like Tetris. If you have like an eyepiece that rests on just one of the corners, it won't rotate, which makes sense. Makes sense on Tetris. Two bricks cannot occupy the same position, so a fallen brick will come to rest upon the first other brick it encounters. Here's the same example again, this time with each brick given a letter so it can be marked in diagrams. Okay, so we have given each brick a letter. At the time of the snapshot, both the side on the x from the side, so the x-axis goes left to right, these bricks are arranged like this. Okay, so we are looking at from the side. This is the z coordinate and x coordinate, and it seems we have an A brick that is already resting on the ground, and then we have these things and a GG on the top. Rotating the perspective 90 degrees, so the x-axis now goes left to right. Sorry, I said x, I think I meant y. The same bricks are arranged like this. Okay, interesting. Like the brick at the bottom, A, is 3 wide, it seems, but here we only see one of those. Like, it seems like a kind of a Jenga tower. Once all of the bricks fall downward as far as they can go, the stack looks like this, where question mark means bricks are hidden behind each other bricks at that location. Okay, so we have more than one brick supported by A, then we have D, E, F, and G on top. Again, from the side, yeah, and here we can see how AA is like a kind of like a Jenga thing, really. BC are on top, and then the E are kind of like BC here, and then FF is on top of the E, and then GG is on top of F. Okay. Now that all of the bricks have settled, it becomes easier to tell which bricks are supporting which other bricks. Brick A is the only brick supporting bricks B and C. Yes, brick B is one of two bricks supporting brick D and brick A. Brick D and brick E. So yeah, that is B. C is the other brick supporting brick D and brick E. D supports brick F. E also supports brick F. F supports brick G. Brick G isn't supporting any bricks. Great. Your first task is to figure out which bricks are safe to disintegrate. A brick can be safely disintegrated if, after removing it, no other bricks would fall further directly downward. Don't actually disintegrate any bricks, just determine what would happen if, for each brick, only that brick were disintegrated. Bricks can be disintegrated even if they are completely surrounded by other bricks, but you can squeeze between bricks if you need to. Okay. In this example, the bricks can be disintegrated as follows. Brick A cannot be disintegrated safely. If it were disintegrated, bricks B and C would both fall. Brick B can be disintegrated. Yeah, we can basically deduce this from here. Like brick A supports B and C, so it cannot be disintegrated, but B and C support the next ones on top, which are D and E. So we could disintegrate B or C. So this is kind of like a Jenga tower, but not really like Jenga, because if you had a Jenga tower that is missing the middle brick here, and you remove other ones on the side, it would for sure fall. But that is on the real world, and this is a magical world where bricks don't rotate. So okay, brick C can be disintegrated, brick D can be disintegrated, yeah, E can be disintegrated, F cannot be disintegrated because it's the only thing that supports G, and G can be disintegrated. So in this example, 5 bricks can be safely disintegrated. Figure how the blocks will settle based on the snapshot. Once they have settled, consider disintegrated a single brick. How many bricks could be safely chosen as the one to get disintegrated? Okay, all right, interesting. So it is sort of a grid puzzle. Well, it is a grid puzzle. Let's take a look at the numbers here. So okay, the coordinates of the bricks are not very big. The set coordinates are the biggest, but it seems like X and Y are very small. It even seems like they are like from 0 to 9, so that's great. That's actually we could totally do this with a 3D grid, like a nested vectors, three levels deep vectors. But well, how are we going to do this? Because these things are still floating in the air, and we need to like make them fall down. And we also need to know, is there any of this resting on the ground? So this would be at level 0, let's say 0 tilde. Well, no, not 0 tilde, 1 tilde. So this one is resting on the ground, it seems. And there are a couple of already resting on the ground, but they are not, interesting. They are not like, in this example, it seems that things are sort of sorted. The one that is resting on the ground and then the ones that go on top are like in that order. But in the actual input, they are not sorted. Like sorted by set coordinate, I guess. Is that needed? I think so. Because the first thing that we need to do is make them fall and rest, like find the resting positions. And if you have things in the, like if you have a brick falling into another brick, you need to make sure that the lower brick is already in its final position. And so I guess we can try to sort these things by set value, and then fall, like make these bricks fall in that order, one by one, and determine where they rest. Something like that. Yeah, but let's open the code. So if I remember where we were, so this is what we had from before. Let's do the usual dance of copying the template. This was, what was the name? I don't remember. Sand slabs, yeah. So it is slabs, not bricks. Sand slabs. But I mean, brick is a better name, I think. And the description calls them bricks. So this is day 22, and we are going to have this input as the sample. Triple click. This is the sample. the output was 5, I think. Yes, so the expected output for the sample is 5, and the actual input is this thing. Okay. So, how do we go about this? So, yeah, the first thing is to make these things fall. And doing that should not be that hard, I think, because these bricks are all single, like straight lines, which should simplify some things, I think. What do we need to do? We need to basically grab each brick, I think, sorted by Z value, and make them fall, and put the final positions on some kind of grid. It can be a 3D grid made of vectors, but it can also be like a hash map of point coordinates, x, y, z coordinates. That would also work, I think. We have notifications here. Yeah, reload the editor because LaTeX and HTML, sure. So yeah, and then I think falling the bricks down should be simple enough. But then what we need to know is which bricks can be removed. So I'm thinking kind of like in terms of Tetris for this, because many years in the past I implemented the Tetris, and it's a very fun thing to do. And one of the things that you can do when you're doing a Tetris thing is that you have like your current piece that is falling down, that you move around, and once it collides with something and it stays there, it's like you lose the piece. You make it so it is part of the grid, you know. And so the grid doesn't remember which pieces they were. Maybe you want to remember for their color or something like that, but it's not like the bricks, the initial bricks themselves are kept on the grid once they are put down there, because they can also be destroyed line by line or things like that, which I do wonder, will part 2 be about removing entire lines, disintegrating lines like Tetris? I don't know. But in this case, we do need to remember when we fall, fall. I'm saying fall each brick, but I don't know if that is like grammatically incorrect. When we make each brick touch the ground or another grid, let's say fall, we sort of need to remember which brick that is. Maybe that could be like an ID or something, or like the position in the vector of bricks or something like that. That makes some sense, I think. And so that then, how are we going to do this thing? Because in the end, we need to iterate over each brick and determine how many of them can be disintegrated. And to determine that, how would we do that? You can think of a couple of ways to do that, because on the description, settle is the position once the bricks are settled. On the description, it talks about this sort of like relationship between bricks, like which one supports or which bricks support each brick. And I think we could find this while we are making the bricks fall, probably. Because yeah, what will make a brick stop? It's either because it will touch the ground, or it will touch, like you try to go one more down and you see if it touches any other bricks, like if any of its cubes overlap at that position with some other bricks, so you know that you cannot occupy that position, so you have to be one above that. That's how you fall these things down, I guess. And at that point, we could already collect this information, like which bricks support each other. That is one possibility. And the other possibility that I was thinking of is, what if, in order to know, because what you need to know is if a brick is safe to disintegrate. So if you disintegrate it, how many, like if any other brick would fall down because of that. So one thing you could do also is to, once everything is settled, like go over each brick and pretend that the brick is no longer in the grid, and sort of like look up that brick and see what other bricks are touching it if you move it up. So that means which bricks that brick is supporting. Then make that brick go out of the grid temporarily, and make each of the bricks that were supported by it try to fall down. And if any of those can fall down, it means that it's not safe to remove it. So you could also do something like that, like you sort of reuse the logic of falling bricks down. sounds like a sort of fun alternative of doing that. But I don't know. I'm more inclined to try to get this information while we are settling things on top of each other. So yeah, let's try to first of all parse this thing. And actually, I think this parse numbers function will be great for this case. This thing was giving me a vector of things, sure. Okay. Yeah, let's parse the bricks first. Oh, I don't know why I touched there. I think I did insert. Let's say let bricks. I probably going to mutate these things because I want to sort them by set, I think. Let's see. Because let's do one thing at a time. What are we going to do? We're going to grab the inputs as usual, split by lines, map each line to something like parse brick, and then try collect, I think, into like a vector of something. Of what thing? Oops. And propagate the thing up. This will be an AOC result, blah, blah, blah. So do I want to model bricks like in a struct or something? Maybe. As for now, let's not do that. Let's have our usual like point thingy. I think everything here seems like well, they are integer coordinates, but there are no negative. No, there are no negative numbers. That's nice. And 0 is the floor. Shouldn't be worried about underflows. Let's use unsigned coordinates. Why not? This will be our point type, and our brick is going to just be a tuple of 2 points. Why not? Point and point. Great. So this will give us a result of a brick. Yep. And this is gonna be, well, a line. And how do we parse a brick? Well, we're going to AOC parse numbers on this line, and then there is one thing that iter tools provide, which is awesome, which is collect tuple, which now makes me think that maybe the parse numbers function could return like an iterator instead of, because here I will be doing like an extra allocation unnecessarily. This thing, however, could give me back an iterator over the numbers, and then let us collect things. Because these parse numbers, but one of the problems is that it returns a result. An iterator over a result. What will this give us actually? Can I say something like let's like, what is this thing giving me back actually? Yeah, okay, it's an option. An option of a tuple. How did I use this? Because I think I have already used it for other things. Yeah, something like that. Okay. My intuition would be to say simply numbers first. Or wait, let's say this okay or simply unwrap, because I don't care about the thing. This will give me a tuple, right? Can I say something like, okay, A and B? What would A and B? Vectors. This is not right? Because this is giving me a result of vector, like iterating. Okay, I'm calling iter over a result, and I didn't know or didn't remember that you can iterate a result. But I don't want that. I want to iterate over the resulting vector. So this is, I think, what I want. And we can also say into iter and consume it, so we have actual numbers here. Something like that. Yeah, now we have numbers, and we could use this as our xy coordinates. So xy set of the first cube, and then x2 y2 set 2, something like that, and then here return basically x1 x2 no sorry x1 y1 set 1 and x2 y2 set 2. Okay, would you like that? Probably you need to say okie dokie. and you still don't like this because you can convert U64. U64, is this parse numbers not generic? Oh, it's not generic. Do I want to make this thing generic now? Or will I just use 64 numbers for this? Let's at least add an error message here. And say invalid brick line. And yeah, the types of these things. I just wanted to see if that would collapse this line, but it didn't, so let's not extract this. I'm very tempted to make this parse numbers return an iterator, but maybe not, because also like I want to handle propagate results up the chain. Okay, but let's try to make this thing generic if it's not too difficult. Like this will be some type T, and the result will be a vector of that type T, right? And probably I want to say that the type T is a number. From string is not satisfied. Yeah. So is it? I think it's because of string parse, but if I put a bound here and say, hey, this can be from string, this must be from string, no? Can I import this? Okay. Parse int error. Here we are returning this parse int error thingy. Yes. Can we say something like I would prefer to have like the T be like a number, but I'm pretty sure that Rust doesn't have a trait for that, for all the numeric types. It's just that I need, like, okay, this thing has to be parsed by the string, but here we are hard coding these. I think we can say like TR, maybe? Oh, look at that. It worked. Awesome. Remove this and use import. Is it building? Like if I do a cargo build, does it build? Well, it has some warnings, but yeah, it does build. Awesome. So now this thing is generic on the type that we expect, of the type of numbers that we need to parse. And I guess it now accepts parsing other things besides numbers, like anything that can be parsed basically. But well, awesome, I guess. So okay, we should be parsing the bricks, right? Let's check that we are doing that. Print line, and we are going to print the bricks as a debug thingy. So let's do a cargo run of kind of this, but with day 22. why don't you want to autocomplete here? Day 22. Oh, because I call this thing day 22. Okay. With a sample. Yeah, it seems to be parsing things. All right. The sample ends in 119. Yeah, sure. That was easy enough. This was sand slabs. I'm pretty sure I typed this at some point, but I lost it for some reason. I don't know. Anyway. Okay, so we have the bricks parsed. What's next? Well, we need to make them fall down. So I guess I will modify these bricks in this vector. Yeah, right. Let's have something like this and say bricks sort by key, and this will give me a brick. And what do I want to do? One thing that I'm not sure about is, are these bricks, like, do they always go from lowest to highest? Like x1 is lower than x2, like lower or equal to x2, and same for y and z coordinates. Like, I don't know if that's the case. And if we want to sort by z, we will have to take the minimum z values of each. So that will be a bit ugly, I think. We would need to do something like, first of all, like accessing the start and the end of this is not very nice. Maybe brick could be a struct with start and end positions. That can be a refactor later on, but okay, we need to grab the z value, and I guess the minimum z value of the start and the end would be like the lowest value of this thing, right? So let's do this and min with b1, 2. Pretty horrible the way that I'm accessing this. Oh, it's even more horrible the way that this got formatted. That's rough. Why is this thing? We can totally say, okay, like start end at least, so it's not so ugly. So start z and end z at the very minimum. Okay. Sure. We have the bricks sorted, and this goes from the lowest to the highest, I guess. So now we need to fold them down, and I just remembered that I didn't start a stopwatch. It's a bit late for that, but better late than never. So how do we fold these things down? Well, I'm going to just have, I think, what information do I need? I think I need to have a grid that maps each position to what brick is in that position. So it can be a mapping of positions, like 3D coordinates, into like the indices on this bricks thing. And by the way, here we are sorting the vector after we have collected things. This can also be done like when we are collecting and say like sorted by key, and do the same thing in there. So this would be nice if we didn't want to modify the bricks afterwards, I think. Mismatch type. Box? What? Oh, because these are results. Yeah, sure. Okay, let's not do that. Let's just collect them first and then sort them. That is fine. But yeah, we need this thing to be mutable also because we want to change the bricks coordinates. I'm pretty sure. Although we could do like a transformation, but either like a mapping of these bricks to like their final positions, and not modify the vector itself. But in any case, we need to have like the information of which brick is in each position. So I think I will just have let's like hash map. Let's say grid, maybe. Just call it grid. It's gonna be hash map new, and I would like this imported. Thank you very much. It's gonna be mutable, and yeah, we're going to now iterate over each brick and modify it. So let's say start end, or just brick in bricks mutable iterator, because we want to mutate each brick. And what do we want to do? Basically, we want to lower their set coordinates, like try to fall down, and if you can, then continue doing so. Like try to fall down by one, because you have to check each position, I think, each set position to see, like, you cannot go straight to 0. And if you can't, then, well, stop there and save that on the grid. So let's sketch that out. This would be something like how are we going to do this? I want to like write it sort of in a high level, but also like why we are falling down. I was thinking about like this relationship of what we collide with. If I want to save it. So yeah, let's say let's start end, something like this. Like brick here is a mutable reference. So here we split the mutable reference thing, and what do I want to do? I want to basically lower it down I'm also thinking about some other thing that I want to like get out of my head first, which is then when parsing, I want to make sure, let's Let's assert that x1 is less than or equal to x2, and same thing for y and z, right? So that they always go in increasing. Cannot compile. Yeah, type annotation. Don't worry about this. It run without following the triggering the assertions. If we run with the input, it also okay. So we always know that x1, like this is the start and this is the end, and it only increases from this to this. So that's awesome. This can be converted into some result if we don't want to crash with invalid input, but let's not worry about that now. I just wanted to make sure that was the case. So in this case, we don't need to say, like we don't need to do a min of this and this. We can just say the z coordinate of the start, because it will be the minimum. Okay, then what else do we want? We want to like iterate, like lower the z value for each start and end, and then iterate over all the points, like starting at the start and going till the end, and see if we collide with something on the grid. Of course, at first, that won't happen. Well, the other condition is if we reach 0. So if the start z is 0 after we lower by 1, then it's on the floor. So we save it there on the floor. That is kind of the first condition. So I want to like do something, make this thing sort of nice, and I feel like using these type aliases is not very nice for the code itself. We are going to modify the brick itself. Yeah. But we don't want to modify if you cannot be in that place. And when we check if it collides with something, that's when we can already know which bricks are going to support the current brick that we are falling down. Yeah, I think so. And then, like, if we have that information of what bricks support this brick that is falling down, like a map from the supporting brick to the brick that is supported, then answering the question that we need to know is like, okay, go for each brick, and for each brick that we are supporting, they can be multiple. If they themselves are supported by only one brick, then we cannot disintegrate it. I think something kind of like that. Yeah, right? It's kind of like that. We can sort of count how many bricks are being supported by only one brick, and that means that all of those supporting bricks cannot be safely disintegrated. That's also another possibility, I think. Okay. I'm sort of thinking of many things at the same time, and I feel like it's getting a bit like abstract in my head. So, so let's try to do simply. This is start and end of the brick. What I want to do is basically tell the brick to like fall down a little bit. So basically get the same thing, but falling down by 1. Then have those 2 things, and in that position iterate the blocks, and yeah, something kind of like that. And we also need to do this on a loop, right? That's also the thing. We are going to loop here. So let's actually write that loop, because I feel like I'm going to forget, because I'm not being the most focused right now, I notice. So what do we want to do? Let's simply say fall 1, pass it a brick by value, and oh, look at that, it's, well, it didn't use the type alias. That's awesome. This is a brick, and it will return a brick, everything by value. And we are just going to extract things like savages, like this. And we're just going to return the same thing, but like this. How about that? How about that? So now these are like the new coordinates of this brick. And we want to test if they are valid. And if they are valid, then we update the brick. No, what do we want to do? Like, if it doesn't collide with anything and it's not touching the ground yet, we should keep. We can update the grid, the brick, sorry, and then keep going. Yes. So what I want to do, like here, to continue the loop, we're just going to say brick. This would be like new starts, new end, kind of ugly names, but that's how we are going to loop and follow down. But we want to check of these new positions. So if a new starts, the set position, and I don't know why I'm using parentheses here, is 0, then we are touching the ground and we need to stop. So here we are going to break out of this loop for sure. But also I want to put this thing on the grid, right? And how are we going to save these things on the grid? I think I want to have like some sort of function or something that will iterate over all the points on a given brick, and sort of save those points on the grid pointing to this brick, something like that, right? And then we will know, yeah, it sort of makes sense, I think. And we don't need to give the bricks names like in the description, because once they are sorted, the positions on this vector will be like their names. So we're just going to use indices. So we touch the ground, we break out of the loop. Great, this is a nice breaking loop breaking condition for this. And yeah, I think I want some sort of way to iterate over all the cubes on a brick. So let's assume that we have that, and let's say something like 4 x, y, z in brick points, brick cubes, brick points, and pass in the brick, I guess. We're gonna do grid at insert, actually. Insert in this x, y, z. Actually, this would be like a point, right? We don't need to extract x, y, z here. We're going to insert the what? The index of this thing. So we're going to enumerate this. Enumerate. We're going to have a brick index b. Point and a b. And now brick points should be a nice function to make. This will take a brick indeed, and it will return an impl iterator of point items, something like that. And you don't already like this because, yeah, I need to return that thing. So now the thing is, bricks can even be like they can even be a single point. Well, let's try to do it in a very stupid way and see if it works. So if, again, I think I want to like destructure all of these things. So if x1 is different than x2, then it goes in the x direction. So can we just return like x1 up to and including x2? And this we need to map. And yeah, this mapping, yeah, the types will not match. It's gonna be ugly. It's gonna be ugly. We could use dynamic dispatch for this, but that sounds bad. How do I want to do that? Yeah, there must be like a good way of doing this. But here I was thinking of doing, okay, this map, we're gonna have an x coordinate and just say, well, what varies is the x, so you can have x and then assume that y1 and z, like the y and z remain the same. So this would be one possibility, and then we have another possibility for when the y coordinates are different. So we're gonna go from y1 to y2. Here we iterate over this, and very similar thing here. This maybe missing an else clause, and the else of everything is just going to do, like the set could be different, but they could also be equal. So we're just going to do this here. Now the problem with this is that the closures are not, yeah, they are not the same type, and that sucks, and that sucks. I could use dynamic dispatch for this, although it seems unnecessary. How else can we do this thing? Well, for now, let's use dynamic dispatch. Let's try to, if I can remember how to do that. So this would be a can I say something like this? Dynamic probably not. Expected static. Can I say a box of blah 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 blah? Syntax error. And here, yeah, we need to box these things. If I box you, would you be okay? Maybe. Like, does this work? Yeah, kind of, maybe. And is the trade bounce? What's your problem? Oh yeah, okay, yeah, because this is, once it is dynamic dispatch, we can say it is dynamic iterator, yeah, sure. Now your problem with this is that this is outliving some things. Let's use a move here. This is not great, but it does compile, so quite ugly, quite ugly. And I don't know if this actually works. I'm tempted to try this thing out first. And well, we can use this loop for sure, but let's do something like print line points for, and we need to print the brick. So let's just simply print the brick. For this brick is going to be, and we're just going to simply do brick points for this brick and collect into a vector. And you don't like this because probably you want to be, yeah, like that. Well, that is the actual input. I want just the sample. So let's see. Here we have a simple one, 118, 119. Yeah, it goes from 8 to 9. That's great. 010 to, sorry, 101 to 121. Yep. Okay. It seems to be working. Seems to be working. With dynamic dispatch, which is kind of horrible, but it is working. Remove dynamic dispatch. Sure. Okay. So we can get rid of this. Go back to our falling loop idea. So now, yeah, we are inserting things on the grid once they touch the ground. That's great. That's great. What else do we need to do? We need to check we need to check when they collide. So can it be the case that we go one down? Like now, if we are already on the ground, we would have already checked collision in the loop before. So I don't think we need to check the collisions before we check the ground. Like the ground, this condition is fine, I think. If we do like print the bricks, let's do for breaking bricks print line. Can I type? If we do this after falling things down, I think this, we're going to see that everything is on the Z position, which is Z1 position, so that's fine. That's not correct because we need to make them collide with each other, but at least the loop is not getting into an infinite loop, like they are reaching Z0. That's great. So, what else do we need to do? Well, if it's not touching the ground, I think we want to do something like this for each point in the brick. Check if there is another brick on the grid already, and if it is, then we are also going to break. So we will ask if some other brick ID is on the grid. So grid get for this point, we're gonna do something. I think we're gonna break out of the loop, but okay, let's think about this. Breakpoints. Maybe breakpoints could just give me back a vector, and that will simplify things instead of like this stupid dynamic dispatch. Maybe the bricks themselves could be, I don't know why I modeled the bricks like this. They could have been like a vector of points. that would have been simpler, I think. And just modify the points. Why did I do this? Anyway, I think that would make things simpler, but let's try to get to the part 1 solution first. We're pretty confident that this breakpoints function works as intended. So, do I want to do this? Because in this case, we know that this point is colliding with another brick ID. This BI, I want to call it brick ID. Okay. Now, breakpoints. This is wrong, right? Oh, no. Here we are letting the brick rest in here. New start. New end. But here, the breakpoints that I want to iterate should not be for the original bricks, should be for sort of the new bricks. So let's actually not have this new start, new end. Let's just simply say new brick. And if new brick starts, and this is horrible, but let's keep with that. Like this horrible formatting is like making me want to have this thing be a struct of start and end. But let's not fall for that yet. We're going to pass the new brick here. So these are the points on the new grid. We want to see if any of these points collides with something. Then we're going to break and put the sort of do this, save the break point. But I think I also want to know, yeah, sort of who is touching this grid. So we can collect this right now. Sorry, I think I'm being like very unfocused while doing this, but I think we can already collect this information now, and then we'll have all the information we need. So let's have another thing. Like a relationship between bricks, which is going to be like supported brick supports, or brick, like when we find another brick ID here, it means that this other brick ID is going to be supporting our brick ID. So let's call it supports, and it's gonna be a little hash map, or even it can be a vector, you know, like, because it's, yeah, let's make it the simplest thing possible. It's gonna be a vector of empty vectors and the length is gonna be bricks length. So this way we don't need to worry about like these things are already initialized as empty vectors. So what we need to say here is what? If it touches something, let's write it down in the most stupid way. Let's mute collides. It's gonna be initialized as false, and then we try to get, for each new point on this new brick, let's say this is, let's call it this thing also new point, like this is a point like one lower than our actual position. You don't like this because what? Well, this is gonna be new brick. This is from before. Oh yeah, I'm missing a let here. So if this is the case, we are going to say it collides. Sure. And we are also going to say that this other brick supports us. Yeah. This can be a case where we are inserting multiple things. So how are we going to say this? Maybe supports, like I would like to say something like supports other brick ID we're gonna, this should be a vector. I don't know why like I should be able to push brick ID. This other brick ID supports our brick ID. And this thing is it's a reference to U size, sure. Can we dereference here? Sure. Collides is true. Awesome. Now I don't want to push if it's not there, so we could use a hash map, I guess, or hash set, sorry, of numbers. How do I say this? Supports. If it contains. If it doesn't contain this, then we push into it. Right? Like, would you like this? Again, not pretty, but I think it should work. Then we mark this thing as colliding, and then we can ask if it collides. And I'm very aware that this could have been done with an iterator methods, and like say, hey, collect all the points that collide with something and blah blah blah. But yeah, I'm doing this in a very imperative fashion. But okay, if it collides, then we're going to do basically this. We're going to set this position, like we cannot go into this new new brick thing. We are going to do basically the same freaking thing as this, right? Probably we can have this on the same if condition, but let's see. If we do this and we're still printing the bricks afterwards, what happens with the sample? So before, this thing used to fall up to set 1, but now it stays at 1 1 1 1 and 5 6, and I think this is the GG brick on the top. Yeah, and 5 6. So it seems to have, yeah, okay, that seems pretty promising already. Seems to be on the final position that it should be. There are some things that set 4, set 3, set 2, and set 1. So that seems pretty promising. And now we want to do like the actual calculation of how many of these bricks we can disintegrate. So let's say, how is it called? How many bricks could be safely chosen to be set? Let's save disintegration count. It's gonna be basically the bricks. We are going to iterate over them, filter by some criteria, and count. And then we are going to print this thing. How are we going to print this, however? I don't know. We are probably also going to need to enumerate this because I want the indices. So enumerate. We're gonna have the brick ID and the brick. And I don't have much space. How are we going to filter here? So we want to count how many can be safely disintegrated. And for that, I don't know if we need the grid we are going to need this support thing. So we should know how many. That is something that we could also print. Maybe it would be nice to say that. Let's actually print it here because we are iterating after all. So print line brick supports, and we're going to print as debug. And here, let's say it's true. Supports what this brick ID supports. And you don't like this because why does enumerate give us a reference to use? Because filter is the one that does that, like the double, like it referencing of things. The brick 0, supports two things. So okay, one easy condition is that if it doesn't support anything, we know that it can be safely disintegrated. If it supports one thing, well, we don't know because that thing might be supported by multiple. In this case, 6 is not being supported by anything else. But for example, here 3 and 4 supports 5. Yeah, okay. So I guess I need also like the inverse relationship, like the is supported by somehow. So for example, can the brick 3 be safely disintegrated? The answer is yes, because everything that it supports is also supported by some other brick. Right. How do we say that? I guess we can say something like, hey, we're going to iterate over all of the things that you support, and if all of them are supported by something else, you can be safely, if it's supported by something else. So this is a brick that is on top of our brick ID. So supported brick ID. If all of them, what do I want to ask? Well, I'm going to do a linear search, which is not great, but probably won't matter. So I want to find if on this supports thing there is any. This is like a difficult thing. Any. How are we iterating this? I want to iterate and enumerate also. This is complicated. This is other brick ID. If there is any other brick, brick ID and other brick supported bricks, I don't know, supports. This is very nested and very ugly, but we're going to, if there is any that is, we need to ask if it's different than ourselves because we want to figure that out. So other brick ID should be different to our brick ID, and other brick supports contains this supported brick ID. Woof! That's a mouthful. And we are not using the brick. Yeah, we're just using the IDs, I guess. I don't know. I have no idea. Yeah, here we're iterating over the bricks, but I guess we could have iterated over the supports. But anyway, how... Look at that. We have 5 over here. So maybe this is correct. I'm not really... like, I typed this and I already cannot flow. Let's actually just simply try the input. And yeah, there's so many supports, and there is 4-to-1 answer. There is an answer. Is this? So look at that. In the end, there is well, there were like 1,000 or 1,200 bricks, and the last ones are not supported by anything. So that is quite promising. There are many things that don't support other things. But yeah, let's try this answer and see if it's the correct one. And it surprisingly is the correct one. All right. I was not expecting that. Let's see what part 2 is about. Man, this solution is quite something. And I don't like it, but let's see what part 2 is about, because maybe part 2 changes everything. Disintegrating bricks one at a time isn't going to be fast enough. While it might sound dangerous, what you really need is a chain reaction. You need to figure out the best brick to disintegrate. For each brick, determine how many other bricks would fall if that brick were disintegrated. Using the sample above, disintegrating brick A would cause all 6 other bricks to fall. Disintegrating brick F would cause only one other brick, G, to fall. Disintegrating any other brick would cause no other bricks to fall. So in this example, the sum of the number of other bricks that would fall as a result of disintegrating each brick is 7. For each brick, determine how many other bricks would fall if that brick were disintegrated. What is the sum of the number of other bricks that would fall? Okay. For each. Okay. Interesting. So it changes things, but does it change that many things? I guess so, right? Because you need to do sort of a chain reaction, but with the information that we already have, I think maybe we can already do something about this, because this is a mess to read, but this basically means we want to see if it supports everything that it supports also has another support, and that is safe to remove. Another way of asking this is, hey, if everything that this supports, how do you ask this? If you remove myself as the support, like my brick ID as the support, and there are 0 other supports for the things that are on top, then it means that they will fall. And so we could ask, okay, if you fall, if you are removed, how many bricks, like sort of as recursively, how many other bricks would fall? Yeah, and I think this could be, part 2 could be solved with the information that we gathered for part 1, although however nasty and ugly it is, our code is. So okay, one thing that I would probably want to first get rid of before trying out part 2 is some of this nastiness on part 1. Here we are iterating over the bricks. We shouldn't be iterating over this. I think we should be iterating over the supports, because that's basically what we are using. Yeah, let's iterate over supports. We're gonna enumerate, and we are going to have a brick ID and supported bricks for this brick ID, right? And this, basically this is gonna be the supported bricks. Well, it didn't change much, but it's fine. Yeah, it's fine. It didn't really change that much. Other bricks supported bricks. Other brick supported bricks. Or other supported bricks. Just to have some consistency in there. Okay, this should still give us the same answer. Yeah. So maybe we can commit part 1. See what happens. If we run the checks, check all. It's failing for this. Why is it failing? For the sample, I mean, doesn't the sample, yeah, it should say 5. Day 22. Oh, I think I have, I have a dirty thing. Let's say cargo clean. This will probably take much more time now to build, but, and the answer, yeah, the answer for this should be this. So while this is running, let's go to the answers file and write this down. And oof, it's taken a lot of time to build the debug build, and now it's built in the release build. We are not seeing the output of the build, but because I silenced those in that check script. We can sort of start thinking about part 2 here. We're gonna, I think, do something kind of similar to this for part 2. Yeah. Filter and count, sure. Okay, everything, all the checks pass, so let's commit this. As ugly as it is, let's say add day 22 part 1 answer. Answer? No, solution. All right. So let's sort of copy some of these. What is it that we are? The sum of the total bricks that would fall. Total fall count sum. So we are, I don't know why. Total fall sum. This would be the answer to part 2. We're gonna print this. We are going to, instead of filtering, we're going to actually map each of these things to how many bricks would fall if we remove this brick ID. And then we are gonna sum these things into something like, I don't know, U64, whatever. Okay, and this, we cannot dereference, and this, sure, we cannot make that from a boolean. And if we have something for part 2 that is like, okay, how many bricks fall if we remove this, we can reuse that thing for part 1 and say, hey, if removing this makes 0 bricks fall, then this is safe to remove, basically. So how are we going to ask this? Is it enough with our supports array, I wonder? So is it enough to say how many bricks would fall if this? Yeah, right, this, I think it's going to be some sort of recursive thingy. Yeah, 6 and 1. 6. Disintegrating the brick A would cause all 6 other bricks to fall, but it doesn't count A. It counts all the other ones, but it doesn't count A. Interesting. Interesting, okay. Let's say count falling can't fall if disintegrated. For this brick ID, and we're going to just simply pass the supports data. Say let's this, we're going to return this thing, but I also want to print it. So if brick ID is disintegrated, count bricks would fall. Okay, this is sort of high-level thing of what we want to do. So yeah, this should be just a slice of, no, this is slice of, okay, yeah, and this shall return, it's going to be a count of something, so probably it's going to want to be a U size, but let's return a U64 and see if that works. So we're not using the supported bricks here because, well, we are going to extract that from the brick ID itself. I think this thing is going to be sort of recursive. So how are we going to do this? We want to iterate over all the things that this brick supports, and for the ones that would fall if this brick is disintegrated, we're going to count those and count also recursively how many bricks will fall if that thing would get disintegrated. Only the ones that would fall with us. So it's kind of a similar thing to what we did here, I think. Spotted brick ID. It's kind of similar, but not quite. Let's this was the condition of this thing being safe to disintegrate. We want to sort of say like the inverse of that. So we are going to get the supports for this brick ID, supported brick ID. Now we're not going to ask all, we're going to map, I think. I touched my glasses and they were smudged. We're going to map to how many bricks would fall. I guess first we want to like filter the ones that would fall if like sort of like the inverse of this condition. Yeah, something like that. Something like that. This is the condition. Oops. This is the condition like to say for the brick ID. Yeah, this is sort of the same condition for part 1, right? Okay, I got a bit confused. Oh, this is saying, okay, if all of them would still be supported, I want to filter the ones that would not be supported. Yes. So let's filter the ones that would not be supported. So here we are asking if any other thing supports, if any other brick supports this supported brick ID, any other that is different than the ones that we have. So those are the things that would not fall. So let's actually filter the ones that would fall. So I negated this condition. And then after filtering, we're going to map into something. And we are gonna sum those things. So we're gonna map to supported brick ID. So this brick then would fall. So I think I'm just going to say 1 plus, because we're going to count this brick as falling, and then do the recursive call count falls if disintegrated for this supported brick ID and the supports. And this is probably a reference which we can dereference. Is that all? Would this thing work? Let's run it for the sample. We did get some answer. If brick 0 is disintegrated, 2 bricks would fall. Not really, but the answer for 5 is correct. 1 brick would fall, which is brick 6. Did I do the... Count false if disintegrated for the thing that it is being supported brick ID. But it's not, no, it's not so simple. It's not as simple as this, I think. Because if you remove something, yeah, if you remove something, you would have to consider everything. Like, it's not just filtering one by one. We would need to consider all of these things removed at once, disintegrated at once. Yeah. Okay. So it's a bit more complicated than this. Sorry. So the first brick to being disintegrated in this example, brick A would cause B and C to fall, but now it's counting those two, but it's not counting anything above, but because it's considering, okay, if B is disintegrated, what will fall? But nothing will fall because C is still there. So we would need to continue on, accumulate the maybe modify the supported things in this recursive call and see what happens. Maybe. If disintegrated, yeah. Well, what if we let's do something kind of ugly, but accumulate in a vector or something, because this is a sort of a recursive call, but we can accumulate things. Right? We're sort of going up and accumulating stuff. If this is disintegrated, the brick ID, filter this, sure. if we say something like things that would it's not like disintegrate, but what would get falling? Other bricks, IT. It's kind of difficult for me to think about this. I think I can get away with passing like a mutable thing, but it's always a bad idea to mix like recursion with like immutable state on the recursive calls. Can we have I have already forgotten. It was like this mute. Well, first it needs a name. So what is that I'm trying to name here? It's things that falling bricks, let's say. Very ugly name, but immutable vector of bricks. Probably should be a hash map or a hash set, but whatever. And we should put all of these into this and then make the recursive call and count, right? I think so. And the falling, does it also count? I think we should start by our brick ID here at the beginning. So let's pass a mutable reference to a vector consisting only of our original brick ID. Super ugly. Okay. And here, let's say, yeah, these are the things. Let's unsupported bricks. Unsupported or like newly falling or whatever. It's going to be this, and just collect these guys. Okay. We're gonna collect this into like a vector. What are we? Yeah, supported brick ID, right? Sure. Unsupported bricks. And of these, we know that these things are going to start falling. I would put them on this vector, right? So I would prefer you to be a vector of usize, not references. So let's use a copied iterator here. So now it should be, yeah, correct type. Let's push all of this into, so falling bricks. I don't want to extend, right? Because extend will consume, I think, what I'm passing. Contents of an iterator. unsupported bricks iterator. Would you be okay with this? Yeah, okay. I think it should. And then I think we'll do unsupported bricks, like something very similar to what we were doing before. This is unsupported brick ID now. Count if disintegrated, this unsupported brick ID, and pass in the falling bricks. Well, this is not complaining about compilation error, but I have no idea. Well, no, we still have the same result as before. So, oh, because, yeah, we are never reading from this. So, falling bricks, yeah, we're just appending things into this, but we should, when checking here, instead of asking this other brick ID different than ourselves, I think what we want to ask here is whether the falling bricks contains, or it shouldn't contain, like it does not contain, this other brick ID. I think if any of this, like, is not falling, yeah, we don't want to consider things that are falling when iterating the supports. So it's not falling, and it's supporting, yeah, and it's supporting this other brick ID, then this should be supported. So if it's not supported, then it's unsupported. Okay, this kind of makes sense in my head. Let's see. Well, 15 is counting, it's over counting now. If brick 0 is disintegrated, 14 bricks would fall. That is too much, too many. And yeah, we are double counting. We are double counting, and this is because, yes, this thing is returning just a count, and we are double counting, yes, because we are being kind of very naive here and saying, hey, if this falls, like if this is disintegrated, it's going to be, these two things will fall, so it's going to be 1 plus how many this is supporting, and 1 plus how many this is supporting, but it will double count, so it's this supports 2, I think here, 3 and 4, so B is supporting 1 plus 4 is 5, this is supporting 1 plus 4, another 5, so that is already 10, and I guess the same thing would happen with the 2 over here, D and E, so it's like doing a double counting problem. We could, instead of returning these, return kind of a collection, like a hash set, so it doesn't kind of add everything up, and so we don't care about repetitions. Would that make sense? I don't even know if it makes sense. Yeah, no, I'm definitely not sure if it makes sense the way that we are adding this thing to these falling bricks, but yeah, let's say instead of saying count false if disintegrated, instead of returning these, let's make it return a hash set of usize, right? And this way we can get rid of duplicates. So how are we going to do that? Well, let's use a normal for loop here, I think. Falling bricks. Yeah, it's actually kind of like the falling bricks is what, like, we are getting, like, I think we would be repeating that from there, aren't we? Like, isn't it the same? Here we are extending, but yeah. Isn't this the output thing? I think it could be. Like, let's make this thing not return anything. And then be, instead of just extending here, let's be a bit more cautious. And well, we could use a hash set here and just push everything unsupported bricks. Yeah, let's actually put this into a variable. This is falling bricks. I'm gonna start with this. Bricks would fall. Let's print falling bricks length here. The count will be nothing. And this should be what gets returned here. And inside here, let's say for unsupported brick ID in unsupported bricks iterator. Falling bricks, we are going to, well, push it in here. If it doesn't contain it before. So if, why am I not using a hash set for this? I don't know. Falling bricks does not contain unsupported break ID. Then we're gonna push it. Okay, great. And then after having pushed everything, we are sort of this +1 we have already done by pushing it here. So we're just going to do the, another for loop like this and do the recursive call. Would that make sense? And you probably want this. Sure, let's be consistent here and, well, no need for consistency. That should be it. Then, oh, this sum should be probably a usize. Fine. What happens now? 14. But why does it say 14? If it says brick 0, if brick 0 is disintegrated, 7 bricks would fall. If brick 1 is disintegrated, 1 bricks would fall. That is not correct. We are overcounting by 1, but only by 1, I think, in all the cases, because we are pushing this already into here, which I think sort of makes a bit of sense to make that algorithm simpler, but let's just subtract 1 from here, and we do have the answer for the sample. It should be 7. Actually, this should be 7 here. Does this also give us the answer for the actual input? Well, it's counting, and it's taking a lot of time, because this is doing a sort of like quadratic problems, and it seems like it got stuck. Huh. Interesting. Do we have an infinite loop? It seems so, right? It shouldn't be taking so long for... Huh. If many things are... Oh no, it just took a lot of time. I was not expecting this. We are having like seriously bad performance. If we run this in release mode, well, it's running faster, but still quite low. But yeah, there are a couple of ones that make a lot of things fall. So I wonder if those linear checks, well, they are quadratic checks, so maybe that's what's breaking everything. This is so ugly, like, it's taking so long. Why is it taking so long? I don't know. There it goes, there it goes. Well, is this the correct answer for part 2? And it is, okay. All right, day 22 completed with a very ugly and slow solution, but look at that. The water is now falling down, and we have almost the last, well, we have the resource going into the last island, to the snow island, so we can then finally produce snow. That's great. And this was an ugly, very, very ugly solution that is using dynamic dispatch. It's using all sorts of ugly stuff. So the first thing that I'm wondering is these falling bricks, which we are using a vector for, and we are doing all sorts of dynamic, well, linear search on this. I thought it was not going to affect the performance so much, but it seems like, well, I'm not sure if that's actually the problem there. And let's also update these. So, well, I'm not going to run the check because we know that it takes a bit of time to run, but this is giving at least the correct answer. Would changing this to use a hash set here give us much better performance? So instead of asking if it contains, well, asking here is fine. We don't need to ask in here. We can just say insert, right? And is there something like extend also? Yeah, it can also be extended. So we can extend this thing with the unsupported bricks iterator. And okay. Would this already make some difference in the runtime? Well, it doesn't compile because, yeah, we are starting with this, which we should instead start from a hash set from iterator, and just start from this thing. How about now? But it's not much faster. But I think it is somewhat faster. Why is it so slow? Yeah, it's definitely faster than before. It is still the same answer, so that's nice. But it's still like super slow. The way we are doing this, we are also doing like linear searching. Like we could have the both relationships, like what things are supported. Like this tells you for one brick what does that brick support, but we could also have the other relationship, which is like for this brick, who supports this brick. And I think having that would make this solution like way faster, probably. But I feel like I should be cutting, like taking a break to think about this a bit more in the abstract and come with it with like fresher eyes to look at this, because this solution is ugly in so many ways, like these nested tuples and stuff. It's not great. It's not great. Let's add these changes to. Let's try this out really fast when we are falling things down here. Yeah, the supports and stuff. Yeah, because also this supports thing is a vector of vectors. But then we are, well, it's fine that we iterate these like this, but then we are also using this with linear searches. So that is for part 1, but we are also doing something very similar for part 2. Supports. What if we have a similar thing as saying supported by, right? And it's kind of the inverse of that. So when we fall, we are putting, like we know that this is putting on all of the, like we are getting all the information of what supports each brick, because otherwise we wouldn't have had the correct answers. But here I think we can also do something similar. Say, okay, this other brick ID is supporting this brick ID. And we can say, hey, if supported by doesn't contain, like supported by this brick ID doesn't contain this other brick ID, we're going to say, okay, then supported by brick ID. So this brick ID is supported by this other brick ID. Well, does this make sense? I think it does. So now we have the bidirectional relationship there. And for example, here, instead of saying supported bricks, one of the supported brick IDs, instead of asking like these, we can just say, hey, other supported brick. If this thing is supported, this is for part 1, but it's basically, I want to see if I get the same answer. Supported by, if this supported brick ID, what is it supported by, and if there is any of this that is different, yeah. If there is any one of these other brick ID that is different to my brick ID, so other brick ID, I think this, oops, this should be yeah, if it is supported by anything other than me. And this should be also like super fast iteration, because the only way that this is false is if the only thing that supports it is myself. And here, of course, you want to be supported brick ID. Okay, does this give us the correct answer for part 1? We are still running part 2 in this slow way. Okay, but part 1 still give us the same answer, so this is equivalent to before, and it's faster. That's awesome. We can also then pass this supported by, and here basically take something that looks the same, supported by, and pass it along. Sure. And here, well, it's gonna be something else, right? We want to see if there is something in the supported by, for this supported brick IDs, that is not falling, right? So it's kind of similar. Say supported by for this supported brick ID. Can I iterate? Is there any other brick ID? So we know that supported brick ID is supported by this other brick, something that is not falling. Yeah. Is this correct? Is this the same as what we were doing before? And does this? Well, it does. It does affect. It made it almost instantaneous. So we can get rid of the printing here. This is kind of ugly, the -1 there, but at least now it's not taking so long to run. And we can do the check. And yeah, everything passes. So yeah, it's a good idea to have this like bi-directional mapping of who supports who and who is supported by who. I guess this is sort of a bi-directional graph. which can probably be modeled in some other way. But, well, this kind of works for me, right? Yeah. Yeah. And these are also like vectors, which they could be like hash sets also, to make them, I don't know, more ideal for looking. But anyway, like it's already much better than before. So yeah, here we can ask this. Sure. So I guess this should be it. This was a very unfocused solve for day 22, but I mean, we did get the answer, and there are some things that I really would like to not do, like this dynamic dispatch here. But I mean, in the end, we got the answer, so that's good for me. I will probably heavily refactor this until I get something that I like. Maybe I will do that in another video, but that will be the end for this video. Oh, I should maybe do a thumbnail, but before that, let's commit this. Say add day 22 part 2 solution, and let's also make a little thumbnail for this. So as usual, let's use toilet, and this was day 22. Was it the last one day 19? Haven't I made a thumbnail since then? What was this day about? It's kind of like a 3D Tetris thingy. 3D Tetris puzzle, just like that. I mean, it sort of describes what this felt like. Yeah, why not? Let's clear the screen and run this again until I have some colors that I like. I'm not really liking these colors. Oh, that's a bit better, yeah. And let's, I don't really want to show this ugly code, but it is the code that I wrote, so let's be honest about this. And that's it. That was this solution for not 2 days, but day 22's puzzle. As usual, if you have been, thanks for watching, and see you later. Bye bye.